Hello everyone. Today I'll be going through the worksheet 8 for Unit 3/4 math methods, and the answers are on the screen right now. So, all right, cool. Let's start. For the first question, this is relatively straightforward. We just find the derivative, right? We just move the power to the front and then reduce power by 1, so we get 12x squared plus 5. And next question, explain why f dash of x is greater than 5 for all x. So if we consider this graph here, it will be a quadratic graph with y-intercept at 5. And since 12x squared is greater than 0, so the graph will look something like this. And that's why this must be greater than 5 for all x. All right, so our next question, this is more testing you guys on the fundamentals of, I guess, cubic functions. So the first question asks, if P, which is a cubic function, have m stationary points, what are the possible values of m? So the way to think about this question is to think that when we take the derivative of P, which I shown here, it will be a quadratic function. And we know that whenever the derivative equal to 0, then the parent, then the antiderivative of that function would be a stationary point, right? So if we think about it, for a quadratic, it can either have 0 stationary point, well, sorry, not stationary point. For a quadratic, it will either have 0 x-intercept, 1 x-intercept, or 2 x-intercepts, which corresponds to 0, 1, or 2 stationary points for P in this case. Now let's consider question 2. If P has an inverse function, what possible values can m have? So maybe you already seen the sketch I've done here. If it's inverse function, then it must be 1-to-1, right? But if we look at the first graph here, I roughly drew it like this one. This is a cubic with 2 stationary points, and we know that it's not 1-to-1. Therefore, so m can't be 2. But other than that, m could have either 1 stationary point or just no stationary point, which might just look something like this, like just it will have like, for example, right, just something like this, I guess, without any stationary points. Then that will still have a inverse function. Therefore, m is just from 0 to 1. So those two values. All right, question C. The first part is asking us to find the inverse function. So again, we just swap x and y. We work out the inverse function here, and then don't forget to replace the y at the end with q inverse of x. And the next question asks us to determine the point of intersection. So instead of equating two graphs together, we know that if it's a point of intersection between a function and its inverse function, and then it must be on the line y equals to x. That's okay. I guess this is not that well drawn, but you guys get the point. So on y equals to x. So we can just solve any of those functions and make it equal to x. And solve this, we get x equals to 1. And then we sub in for the y value, which is also 1. Therefore, well, to be fair, we don't even need the subbing anymore, because if we think about it, it's on y equals to x. So the y value must equal to x. Therefore, the final point is just 1 and 1. The next question asks if G has exactly 1 stationary point, find the value of C. So first we do the derivative, which we get G dash of x is 3x squared plus 4x plus C. And consider that if a cubic has 1 stationary point, then that means its derivative, the quadratic, must have only 1 x-intercept. So we use the discriminant function and make it equal to 0, and we get C is 4 and 3. And the final question is, again, if this stationary point occurs at the point of intersection, which for g of x and its inverse function, we find value of k. So first of all, we want to know what x is, right? So we know what the c value is, so we can complete g dash of x here. And to make this equal to 0, we'll know what x is the intersection point. So we worked out x is negative 2 on 3, and we know that the y value will also be negative 2 on 3 because of its intersection point of a function, its inverse function, so it must be on y equals to x. And finally, we just sub in y and x into g of x to find what k is. In this case, k is negative 10 on 27. Hopefully that's clear enough for you guys. If you guys have any other questions, make sure to let me know. And so for this time, we introduced a new, I guess, how do I say, Google Classroom. So every time you guys finish your homework for each week, make sure to go on the link and then just say you finished. You don't have to submit it, just say you finished. And you can also use that link to say, like, for example, I finished this, but I'm not sure about this certain question, right? And I'll be looking at those every week, and I'll be like helping you guys with questions you guys need help with, basically. All right, cool. See you next week.